previous class, we were describing the short circuit studies, and we told the various introduction we have given the various type of faults in the power system. Out of those various faults, how to handle the symmetrical fault, that is called the balance fault. We have described what is the transient current, what is the steady state current, and what is the net current flowing during the fault. And according to the net current flowing, and this net current, especially the transient current, depending upon the time, because finally it stabilizes or it decays. So finally transient current decays and only steady state current remains. So depending upon, and total current depends upon the time, starting from 0 to few millisecond. Few millisecond means say 100 to 200 millisecond, or few cycles. Each cycle is of 20 millisecond, so we can say 5, 6, 7, 8 cycle. And depending upon the nature of fault, there will be we consider, and depending upon what type of system is there, how much protection we want, accordingly we select the circuit breaker. And the selection of the circuit breaker will depend upon at what time we want to open the faulty current. So if it is instantaneous, or it can be delayed by some time, whether it can be afforded or not. So accordingly, we select the circuit breaker. So for selecting the circuit breaker, what should be the fault current? It is very much important to know that. And as far as symmetrical fault is concerned, we told when all the faults or all the phases are connected to one place and to one point, then it becomes the balance fault, because balance means the current in each phase will be the same. And how to solve the balance current, how to solve the fault current during the balance fault, we told that we consider the system is considered at a no load first. First of all, we consider system is at no load, because load current in comparison to the fault current is small. And later on, we incorporate the effect of the load current to find the actual fault current. And we assume shunt element of the transformers and transmission lines are neglected, because the current flowing to the shunt elements are small, because current flowing mainly the series elements. In the shunt, the shunt element means transmission line consists of the shunt capacitor, and this is very impedance or reactance is very high. That's why that shunt current will be negligible. And during the fault, even then we neglect the load current. Since we neglect the load current, in comparison to the load current, the shunt current is very, very small. And how to solve the symmetrical fault analysis? We know, first of all, we draw the single line diagram. Single line diagram. You know how to draw the single line diagram. Transmission line is represented by a single line, that is resistance and reactance. And transformer is represented by simply only a reactance. Then generators are represented with the help of voltage sources. Then, so this is the single line diagram. Then we convert everything into per unit. Per unit means transformer in the power system, everything is done in the per unit system. Per unit, and it is easy always. Per unit means we select the base MVA, and wherever power, active power, reactive power is there, that is divided by a base. We also select the voltage base, and accordingly the base current, and dividing the actual voltage and actual current with the help of the base value, we find the per unit values. Then, depending upon where the fault has happened, and at that point where the fault has happened, at that point we find the impedance with the help of the Thevenin's theorem. And we also find the Thevenin's voltage normally, because since the load current is 0, so Thevenin's voltage will be 1 per unit. And so fault current is the voltage divided by the impedance. Thevenin's voltage divided by Thevenin's impedance. Thevenin's impedance, or impedance of the net of the system, plus the impedance by which the fault has been occurred. And if you multiply this fault current into the base MVA, then it becomes the fault level. Once we calculate the fault current, now we find the actual fault current. Actual fault current means before the load, before the fault has opened, when the system was working at normal operating condition, at that time we find what is the load current. And you know how to find the load current in normal condition? With the help of the load flow study. If its system is small, directly we can find what is the fault, what is the actual load current. If the system is slightly big, then we can apply the load flow study to find the current in each component or each branch. And when we obtain the fault current and that fault current is divided into fault current with the help of fault current is the net current flowing into the fault. This current can be seen that how much of this total current is divided into different components. If we know the total current, then with the circuit diagram we can divide this current into each component. And before load also, before the fault has opened, we know what is the load current, and net fault current will be the algebraic sum of the two. Suppose in one transmission line, say transmission line from A to B, it is a point, it is a B point. From A to B, load current was the 2 ampere in this direction. And when you apply the fault current saying the current flowing from B to A 40 ampere, so net current will be as per the superposition theorem, net current or net fault current will be the algebraic sum of the two. So with the help of this superposition theorem, we incorporate the effect of the load current, and finally the actual value of the fault current can be obtained. Okay. So we apply the superposition theorem to know the actual value of the fault current. Is there any question up to this point? If you have some question up to this point, please ask so that we can go to the unbalanced fault. Hello?
Yes, sir.
Is there any question up to now?
No, sir.
Okay. Then we know the superposition, we know that unbalanced fault, unsymmetrical fault, which are also called the unsymmetrical fault. Unsymmetrical fault means current flowing in each phase may be different. Phase A, phase B, phase C. In the balance fault or symmetrical fault, current flowing the phase A is same as of phase B or phase C. But in case of this unbalanced system, unsymmetrical fault, current into each phase may be different, because unbalanced fault it may be of the type single line to ground fault, line to line fault, or double line to, means the fault happen only in one line. Then this current will be different than the, say, current fault occurs in the phase A, then it will be different fault current will be different than for the fault current in the phase A, phase B and C. Similarly, line to line fault, then current into the phase V and phase C will be same because line V and C has been connected, but current into the phase A will be different. So in this way, the for different type of faults, depending upon single line to ground, line to line, or double line to ground, the current or fault current in each phase will be different. Now, so system, since the current is different, so the system become unbalanced. All the system is unbalanced because of the unbalanced fault. So current will be different, and everything, voltage at different component, different parameters of resistance, inductance, capacitance, or the different elements. Current and voltage at different elements in the power system will be different. Now question is how to find out and how to solve such problems to find the fault current in each phase. So then this scientist C.L. Fortes, he told in 1988 that any unbalanced system or any unbalanced phasor, which is a three-phase type, any three-phase unbalanced system can be sum up or can be made equal to the sum of three-phase balanced phasor, means three-phase balance system, one balance system, second balance system, third balance system, and sum of the three means the three balance system, the sum of the three balance system individually. एक बैलेंस सिस्टम है, दूसरा बैलेंस सिस्टम है, तीसरा बैलेंस सिस्टम है, इन तीनों बैलेंस सिस्टम का सम can be a unbalanced system, or you can say one unbalanced system can be divided into the three balanced system. Okay, so if the system become unbalanced or unbalanced phasor, we can convert it into the three balanced system, and those three balanced system are called as a positive sequence, negative sequence, and zero sequence. Positive sequence means phase A, phase B. This is the phase A1. Otherwise, हमारा say unbalanced system is phase A, B, C, where A and B magnitude wise not equal, or phasor wise also not displaced by 120 degree. It can be 100, it can be 90, it can be 20. Phase difference is also not 120 degree. Otherwise, in the balance system is 120 degree, or magnitude is also not same. And that such unbalanced system can be made equivalent, can be made sum of these three, 1, 2, 3. One means positive sequence, means this is a balanced system having VA1, VB, VC1. It is a balanced system with magnitude VA1 is equal to VB1 is equal to VC1. इनका magnitude सबका same है, and they are displaced by 120 degree to each. So it is a balanced system. And why it is called a positive sequence? It is a positive sequence because this sequence of this is same as of sequence of unbalanced system. Sequence means when phase A comes, then phase B comes, and phase C comes. Then in the same sequence, the phase of this is coming. मतलब इसमें जरूरी नहीं है 120 डिग्री फेस हो अनबैलेंस में. फेस ए आया, फिर बी आया, फिर सी आया, लेकिन उसमें 20 का, 80 का और 120 का डिफरेंस आ सकता है. बट हियर फेस डिफरेंस विल बी 120 डिग्री इन ईच and magnitude will be same. So it is a balance. Since the phase sequence of this and this is same, balanced and unbalanced system, this was the unbalanced system and here it is balanced system. If the phase sequence is same, then it is called the positive sequence. If the phase sequence of this is opposite to of the phase of unbalanced system, say unbalanced system is ABC and it is of ACB, means A पहले आ रहा है, फिर C आ रहा है, फिर B आ रहा है, then it will be and it is a balanced. So this is the negative sequence, and this is the zero sequence. Phase of all, phase A, phase B, phase C, phase of all the voltages, all the three phase, they are in the same direction. Same direction means otherwise direction not north east south direction. They are in the same phase. Same phase means जब ये मैक्सिमम होगा तब ये मैक्सिमम होगा, जब ये उसी टाइम ही मैक्सिमम होगा, ये मिनिमम होगा तभी ये मिनिमम होगा, तभी मिनिमम होगा. से 20 डिग्री पे जो इसकी वैल्यू होगी वो इसकी वैल्यू होगी वो इसकी. ये दिस इज द जीरो सीक्वेंस. सो एनी अनबैलेंस्ड सिस्टम दिस कैन बी कंसिडर्ड एज ए सम ऑफ all these three phase systems, where this is called the positive sequence, negative sequence, zero sequence, or you can say sum of the three sequences called the positive, negative, and zero sequences. Okay, is there any doubt up to this point? Like this is the, say, unbalanced. This is unbalanced system. You see this VA0, sorry, VA, this dotted line, this VA. Are you able to see this VA? Mitesh?
Yes sir, yes sir.
ये VA, देखिए VA, then this is VB up to here. देखिए इसका magnitude is more than magnitude of this VB, and VC, magnitude of VC is only very small. This is this, and phase difference between A to C and C to B, they are not 120 degree. So you can say this VA, VC, and VB, they are unbalanced. This unbalance can be made equivalent to the sum of these three: phase A, phase B, phase C. ये देखिए, this is a positive sequence, this is negative sequence, and this is zero sequence. देखिए इसका magnitude है ABC, and this is moving from ACB. ACB में जो इसका था A, फिर C but here it is a balance 120 degree each, here it is not balanced. So इसका, this is a positive sequence, and this is a negative sequence. इसमें देखिए anti-clockwise if you move ACB, but here it is a ABC. This is moving ABC. First A is coming, then face B is coming, face C is coming. So this is a ABC, and magnitude of them both are same. Magnitude is same, direction positive and direction negative. This is zero sequence. All are in the same direction, but magnitude is same as of this. Magnitude सबका same है, but direction is same in one direction. And sum of this 1, 2, 3. एक को आप चेक कर लें. देखिए VA1 this direction is this. VA1 is like this. Same magnitude. ये आपने VA1 यहाँ ले लिया. VA1. Okay. And VB1. Sorry. हाँ. VA1 इसका all सभी का face of this. इसका फेस, इसका फेस, इसका फेस, इसमें सभी का ए फेस ले. VA1 इसका फेस VA2. तो ये देखिए इसका डायरेक्शन सेम हो गया VA2. ये VA0. तो सम ऑफ देम इज इक्वल टू दिस VA. सिमिलरली फेस B and फेस C means simply we can say this unbalanced phase VA, VB, VC which are unbalanced, it is a sum of zero sequence of A phase, positive sequence of A phase, negative sequence of A phase. Similarly, इसका जो V phase है, suppose it is a B, unbalanced system का V phase, it is the sum of zero sequence of B phase, positive sequence of B phase and negative sequence of B phase. मतलब इसका A phase unbalance का इन सभी के A phase को लेंगे, B phase इसका जनरेट करने के लिए सभी का B phase लेंगे, इसका C करने के लिए सभी का C लेंगे. ठीक, सभी का मतलब जीरो, पॉजिटिव एंड नेगेटिव. एंड this can be, they can be selected such as that some of them will be equal to this. This is the theory that how we can represent unbalanced system into the balanced system. And this, since this equation, first equation written again here, and we know this B phase, it is a VV0. This VV0 means this. This VV0. This is same as of this. Since the magnitude is also same and direction. In case of a zero sequence, magnitude and direction both are same. So BV and VC can be written as a VA0. VV0 था, ये VC0 था, दोनों को हमने VA0 लिखा because VA0 is nothing but same as of VV0 and VC0. इनका magnitude direction सबका same है. So we can write in place of VV0 here VA0, here VC0, again VA0. Okay. Then this VV1, B phase की बात कर रहे हैं. VV1, VV1. This is, what is this? We convert into the, देखिए हर एक का so yes. So this VV1, we will in case of a balanced system, we study only the one phase. Here also we will study the one phase of each. इसके तीनों phase separate study नहीं करेंगे. इसका phase ये study करेंगे, इसका ये, ऐसे ही हर एक का एक phase study करेंगे. VA1, VA2, VA0. And we know if we study VA1, we know what about this. If we study this, we know what about this. We know this, we study this, and what we know. So everything is converted into VA1, VA2, VA0. So this VV1 is nothing but magnitude of VV1 is VA1 with the angle of this is 120 and 120, 240. So VV1 is equal to VA1 and 240 degree angle. Similarly, VV2 means this. VV2 is the VA2 plus 120 degree. So it is a 120 degree. Similarly, VC. So these three equations, after converting into the A phase only, सभी का A phase में convert कर दिया, A phase. We can write like this. And angle 120 degree is, in short, again writing 120 degree, we write it as a alpha. So here it is alpha, here it is alpha, and 240 means alpha square. Because alpha square means if you make the 120 and 122 times, it will be square, but so in an angle it will be 240. So alpha square is equal to 240. And alpha q, 120, 120, 120, 360 is equal to 1. So 360 is nothing but, alpha q is nothing but 1. And so from here, 1, alpha q is equal to 1. 1 minus alpha q, 1 minus alpha q is 0. And if you open this 1 minus alpha plus alpha, if you open this 1q minus alpha q plus 1 plus alpha square is equal to 0. So this is also 0. Means while further analysis, we will need this. We will have the requirement of this. That's why anyway, so these three equations are written like this in the matrix form. This is an unbalanced system, VA, VB, VC, and this is this, VA is equal to 1, 1, 1, VA. Is it clear or not, this matrix form? Those three equations as shown above are written here in the matrix form. Is this point clear?
Yes, sir.
Sangeeta?
Yes, sir.
And we know alpha is equal to 120 degree. Cos and anything, cos any alpha, it is power angle alpha can be written as a cos alpha plus j sin alpha. So it is since it is a 120 degree, cos 120 plus j sin 120 degree. Cos 120 degree minus 0.5 and j sin 120 degree is this. So alpha is nothing but, sometime if required, you can use alpha is equal to this. Okay. Now, alpha, this matrix A, this matrix is called as A here. So it is VABC, this column matrix VABC, in the short we can write VABC like this. A column matrix consisting of voltage VA, VB, VC, phase A voltage, phase B voltage, phase C voltage. In short, we can write it as a VABC. This is matrix A, symmetrical component matrix A. So this is zero sequence, positive sequence, negative sequence. So simply in short, we can write V012. Okay, means we can convert. If we have unbalanced phasor this, then we can find this symmetrical component, zero phase, positive, zero sequence, positive sequence, and negative sequence. So this zero sequence, positive sequence, negative sequence is nothing but A inverse of this. Okay, and if you do the inverse of this, simply you will not leave it as it is. देखिए जो मैं कह रहा हूं उसे ऐसा नहीं है सुनकर छोड़ देंगे, इसका इनवर्स आप निकालिए. You do your inverse in your notebook or your lecture notebook. You take the inverse of this. When you will do the inverse of this, you will need these equations. अगर आपका इनवर्स निकालेंगे तो आपको इसकी जरूरत पड़ेगा. Which I just explained. You will need these equation. इसकी जरूरत पड़ेगा अगर आपको इसका इनवर्स निकालेंगे. So do the inverse of this, and simply while doing you will find the determinant of this. While doing the inverse, you will find the determinant will come to be 1 by 3 here. It will be 1 by 3, and this will be the transpose. Like so, you try it. Don't leave it to me. You find out the inverse of this. It will be like this. Okay. Similarly, this definition or this equation is valid for the current also. जैसे ये वोल्टेज के लिए वैलिड है, ऐसे ये करंट के लिए वैलिड है. मींस VABC is equal to A symmetrical component matrix and zero sequence, positive sequence, negative sequence voltage. Similarly, this will be the valid for the current. Means positive unbalanced ABC current will be equal to the current in zero sequence, positive sequence, negative sequence, and this related. It will be related with the system this matrix A, symmetrical component matrix A, and inverse of this you will need when you will find if you want to find out these component if the unbalanced ABC currents are given. Okay. So now we will see whether by doing this by doing this means after converting a unbalanced system into three valence system, after converting any unbalanced system into three valence system, whether we are doing justification or not, whether the power consumption is remain the same or not. अगर हमने unbalanced system लिया और उस समय कितना power consume हो रहा है, fault current multiply by the voltage will be the power consumed. So power can be two types, active power and reactive power. In general, we can write it as a complex power. Power is normally Vi cos phi plus J sin phi. This is written as a Vi complex conjugate. I cos phi plus Ji sin phi is called as a I complex conjugate. So it is a power consumed in the phase A. Power consumed means complex power consumed into the phase A is Va Ia complex conjugate. Power consumed in the phase B is given by this Va Iv complex conjugate. Power consumed in the phase C. Yes.
सर ये जो A इनवर्स है इसमें A की जगह पे अल्फा आएगा ना, वन सेकंड कॉलम में 1 अल्फा अल्फा स्क्वायर, इसमें ये A लिख रखा है सर।
हाँ हाँ नहीं, ये जो A है ना, ये इसका इनवर्स लेंगे तो ये पूरा, ये इसको इनवर्स, ये जो पूरा वैल्यू है ना, दिस इज ए इनवर्स।
यस सर, ये A इनवर्स है तो सेकंड कॉलम में 1 अल्फा अल्फा स्क्वायर ऐसे आना चाहिए, ये A नहीं आएगा सर इसमें शायद।
कहाँ पे कह रहे हैं यहाँ पे?
यस सर, इस A की जगह
इसमें बात कौन से नंबर पे?
सेकंड करंट में, बीच वाली लाइन में सर, सेकंड में। ये नो सर, इससे ऊपर A इनवर्स वाली जो है ना सर, हाँ इसमें ये A है, इसकी जगह पे अल्फा नहीं आएगा क्या सर?
कहाँ पे अल्फा था?
यहाँ पे, हाँ यस सर।
ये नहीं 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 नहीं,
इससे ऊपर, हाँ इस A की जगह पे सर। ये A कहाँ से आ गया?
मैट्रिक्स की बात कर रहे हो या ये A की बात कर रहे हो?
मैट्रिक्स की सर, मैट्रिक्स की।
इसमें, हाँ इसमें बताओ।
हाँ इसमें तो सर जो ये बीच में A लिखा हुआ है सर, ये आपने,
ये हाँ लिखा है,
यहाँ पे अल्फा आएगा।
हाँ ये सब अल्फा ही है, ये लिखने में ये तो उसमें फर्क
हाँ,
है।
यही पूछ रही हूँ सर, मैंने सोचा ये A कहाँ से आ गया एक।
नहीं नहीं नहीं, ये सब अल्फा ही है, ये तो टाइपिंग में प्रॉब्लम रहता है।
ओके सर, थैंक यू।
तो दिस इज द power consumed in the phase A, unbalanced system phase A, power consumed in the unbalanced system phase B, power consumed in the unbalanced system of phase C. Okay, so this is the net complex power in all the three phases. Now if we convert this can be, this equation means this is the total power as complex power consumed in all the three phases of unbalanced system, and this can be written as a, this if you write this equation can be written as a VABC. It is a row matrix, it is a column matrix, and this is the complex conjugate. There is no problem in writing this equation into this form, in the matrix form. Okay, and this VABC, you see here VABC, it is a column matrix, and since it is a row matrix, so this is nothing but transpose of that. इसको आपने VABC कहा था, देखिए this VABC is column matrix VABC. Since it is a VABC row, so it is a transpose of that. Okay, and VABC like this IABC, so it is a complex conjugate of IABC. This in short means we write, this is short form of this, otherwise there is no need of this, simply you see this equation. Now this VABC, you remember, you see this VABC is A of V012. इसको we want to write, we will write in place of ABC as a symmetrical matrix, symmetrical component matrix and sequence voltages. इसकी जगह VABC की जगह ये लिखेंगे. So here you can see VABC की जगह क्या लिखा, A V012. ये ट्रांसपोज था तो ट्रांसपोज लग गया, ये IABC की जगह सेम जैसे वोल्टेज का होता है वही करंट की जगह A सिमेट्रिकल कंपोनेंट मैट्रिक्स प्लस B012 सीक्वेंस करंट्स। नाउ द ट्रांसपोज ऑफ द टू मैट्रिक्स, ये भी एक मैट्रिक्स है, ये भी एक मैट्रिक्स है, ट्रांसपोज ऑफ द A इंटू बी, अगर आप A इंटू बी का ट्रांसपोज करेंगे तो पहले B का ट्रांसपोज देन A का ट्रांसपोज, ऐसा आएगा। B का ट्रांसपोज प्लस A का ट्रांसपोज। ऐसे ही इसमें इसका कॉम्प्लेक्स कंजुगेट करेंगे, पहले इसका कॉम्प्लेक्स कंजुगेट, सॉरी इसमें सिंपली एज इट इज, इसका कॉम्प्लेक्स कंजुगेट फिर इसका कॉम्प्लेक्स कंजुगेट, ट्रांसपोज में अपोजिट होता है। सो दिस इज द, नाउ दिस यू सी मींस व्हाट वी डिड, या क्या किया हमने, वी कन्वर्टेड दिस अनबैलेंस सिस्टम इनटू द बैलेंस सिस्टम वेयर V012 zero sequence positive sequence negative sequence current, it is the zero sequence positive sequence negative sequence current, it is a voltage and it is a transpose A, where A is, what is A is this, ये आपको पता ही है, this is A, तो A का ट्रांसपोज ही आएगा, A आपको पता है, उसमें यहाँ अल्फा अल्फा था, ये अल्फा स्क्वायर हो, A ट्रांसपोज हो गया। एंड इसका कॉम्प्लेक्स कंजुगेट, A का कॉम्प्लेक्स कंजुगेट मीन अल्फा स्क्वायर, देखिए अल्फा क्या था 120 डिग्री और अल्फा स्क्वायर क्या था 240 डिग्री, तो कॉम्प्लेक्स कंजुगेट उसका करेंगे और cos थीटा प्लस जे साइन थीटा, कॉम्प्लेक्स कंजुगेट करते हैं cos थीटा माइनस जे साइन थीटा, तो वे आपस में कन्वर्ट हो जाएगा। यू डू दिस देन इट विल बी अल्फा की जगह अल्फा स्क्वायर की जगह अल्फा और अल्फा की जगह अल्फा स्क्वायर, और फिर इसको आप मल्टीप्लाई करेंगे, व्हेन यू मल्टीप्लाई दिस, ओके, व्हेन यू विल मल्टीप्लाई दिस, इसको मल्टीप्लाई करके इसे भी आप ऐसे ही नहीं छोड़ेंगे, यू ट्राई इट, जब तक आप खुद नहीं करेंगे बाय योर ओन हैंड योर कॉन्फिडेंस विल नॉट बी बिल्ड अप। तो इसको मल्टीप्लाई करके देखिए, व्हाइल डूइंग दिस मल्टीप्लिकेशन और एनी मैथमेटिकल कैलकुलेशन यू विल रिक्वायर दोज 2-3 इक्वेशंस व्हिच वी हैव रिटन अबव, कि अल्फा स्क्वायर एंड व्हाट इज द 1 प्लस अल्फा स्क्वायर इज इक्वल टू 0, तो इनकी जरूरत पड़ेगा जब आप इसको मल्टीप्लाई करें, बिकॉज कहीं पे अल्फा स्क्वायर मल्टीप्लाई होगा अल्फा 4 विल बी अल्फा रेट 4 विल बी इक्वल टू दी अल्फा, बिकॉज अल्फा क्यू इक्वल टू 1, ऐसी जरूरत पड़ेगा। सो व्हाइल डूइंग दिस मल्टीप्लाइंग दिस यू विल फाइंड इट इज 3 ऑफ दिस एंड दिस 1 1 1, इट इज आइडेंटिटी मैट्रिक्स। So in place of A transpose A, you can write 3 into I. I is identity matrix, so there is no need of this. Here you can write as a 3. So it is nothing but here it will be the 3. Means ये क्या हो गया आपका? It is like it is like 3. So ये 3 इधर आ गया. Again this is a transpose V012 means V012 column matrix, since it is a transpose, so it is a row matrix. Here V012 ये complex conjugate है. If you multiply this row into this column, it is like this. And what it indicates? ये क्या indicate कर रहा है? Zero sequence का power. Voltage of zero sequence multiplies the current of zero sequence. So it is a power consumed in zero sequence in phase A. So whatever power, since it is a balanced system, जीरो सीक्वेंस अपने आप में बैलेंस है, पॉजिटिव सीक्वेंस अपने आप में बैलेंस है, नेगेटिव सीक्वेंस अपने आप में बैलेंस है। सो दिस जीरो सीक्वेंस फेस ए का, जीरो सीक्वेंस ऑफ फेस ए, दिस इज द पावर एंड पावर इन ईच फेस विल बी सेम। फेस बी, इसके जीरो सीक्वेंस के फेस बी में भी उतना ही पावर कंज्यूम होगा जितना फेस सी में होगा, जितना फेस ए में होगा। सो पावर कंज्यूम्ड इन फेस ए, सो इट मींस 3 मींस पावर कंज्यूम्ड इन द ऑल 3 फेसेस ऑफ द जीरो सीक्वेंस, power consumed in all the 3 phases of positive sequence, power consumed in all the 3 phases of negative sequence। इसका मतलब क्या हुआ? जीरो सीक्वेंस के सभी फेस का पावर, पॉजिटिव सीक्वेंस के सभी फेस का पावर, नेगेटिव सीक्वेंस के सभी फेस का पावर, दिस विल बी द सम ऑफ, दिस विल बी द सेम एज ऑफ एस मींस पावर कंज्यूम्ड इनटू द अनबैलेंस सिस्टम, पावर जो हमारा अनबैलेंस में हो रहा था। इससे ये प्रूफ हो गया कि वी कैन consider if we consider any unbalanced system into 3 balanced system like this, then this consideration is okay, we can do it, okay, so there is no problem in doing this। Is there any question into this? You please ask। यहाँ तक अगर आपको कुछ क्वेश्चन है तो आप पूछ सकते हैं, ओके, पूछना चाहते हैं? Sapna, you want to ask anything?
No, sir.
So now देखिए इस पे तो we reached up to this conclusion that any unbalanced system can be assumed equal to the three balanced system. Consider into can be converted into three balanced system. Now अब जैसे हमारा कोई अनबैलेंस फॉल्ट आया, जहां पे भी वोल्टेज होगा आपने उसे थ्री बैलेंस में कन्वर्ट एज्यूम कर लिया, प्रिज्यूम कर लिया. नाउ क्वेश्चन इज हाउ दीज अनबैलेंस, हाउ दीज थ्री पॉजिटिव सीक्वेंसेस, how the positive sequence, how the negative sequence, how the zero sequence, they will behave different parameters of the system. जैसे ट्रांसमिशन लाइन्स है, पावर सिस्टम में क्या है, ट्रांसमिशन लाइन्स है. हाउ ट्रांसमिशन लाइन विल बिहेव व्हेन देयर आर थ्री सीक्वेंसेस, पॉजिटिव सीक्वेंस है, नेगेटिव सीक्वेंस है, जीरो सीक्वेंस है, तो हर एक के लिए कैसे बिहेव करेगा. बिकॉज पहले क्या था, बैलेंस सिस्टम में क्या था, एक ही सीक्वेंस होता था. पॉजिटिव था तो पॉजिटिव सीक्वेंस है, मतलब बैलेंस सिस्टम इज पॉजिटिव सीक्वेंस. अगर नेगेटिव है तो इट इज आल्सो बैलेंस, तो उसके लिए पावर सिस्टम कैसे बिहेव करेगा. जीरो सीक्वेंस है तो कैसे बिहेव करेगा. तो हर एक के साथ कैसे बिहेव करेगा, और इन जनरल व्हेन ऑल आर देयर देन हाउ इट विल बिहेव. सो वी विल सी हाउ द ट्रांसमिशन लाइंस विल बिहेव to these sequences, sequence voltages, how the transformer will behave these sequence voltages, how the generator will behave these sequence voltages, that we will see, because these are the main devices in the power system. So when we will know how they will behave, then accordingly we will find the what is the net fault current in case of a unbalanced system. So first of all, in the next class we will take how the behavior of these system parameter with respect to the